Good morning, Looster Colts. Today we're going to do Readiness Assessment 3, and we're going to do the front half, which is numbers 1 through 8. So in question number 1, it's talking about our x values and our y values, and if we remember, x values are going to be our inputs, and our y values are going to be our outputs. So whatever we put in results in what comes out. So we're just going to go through these multiple choice, which statements are true about the inputs and outputs. Select all that apply. Okay, and oftentimes when it says select all that apply, it means that there's more than one. So we have some coordinates, and we look through. If we plug in a 2, a 4 comes out. When we plug in a 6, a 3 comes out. When we plug in a 5, a 4 comes out. A 7, a 3 comes out. And an 8, a 2 comes out. So if we look at these multiple choice options, the first one says there's only one input for every output. So looking at our options, we got to remember which one's input and which one's output. So input is going to be our x values, and output is going to be our y values. So this is saying that there is only one x value for every y value. And if we look, this point right here where we have these 4s, we'll make it so that this one is not true because we have two outputs for different inputs. So we're going to cross that one off. If we look at B, it says that there's only one output for every input. And as we saw up above, every time we plug something in for our x, we only got one output. Now some of them are the same, but we only get one. So our first option we're going to select is going to be B. If we look at C, it says there is more than one output for some inputs. And looking at all of these, we don't have more than one output for some of these inputs because we don't have any repeated inputs. So like I didn't plug in a 2 and get two different ones. Or I didn't plug in a 2 and have two solutions that came out. So it's not going to be C. So then I'm going to go down to D. It says there is more than one input for some outputs. So this is my x again, and this is my y. And this is saying that there is more than one x for the same or some outputs for my y value, which we see with our highlighted one up above. When I plug in a 2, a 4 comes out, and when I plug in a 5, a 4 also comes out. So for this one, we're going to get D. So moving on to number 2, it says which equations have exactly one y value at any given x value. Select all that apply. So if I look at this first one, if I plug in any of x value, it's going to give me just one value that comes out. So I'm going to select A starting off. So say we pick the same value. Let's say we pick the number 1. So if I plug in for my first equation, I plug in a 1, I'm going to end up with a -1 for my y. If I look at B, well, I can plug in a 1, but then it would say 1 equals 4, and that's not going to give me a y value. So we're not going to select B in that case. If I look at C, if I plug in a 1, I'm going to end up with 1 squared, and that's going to give me 1, which is just a value. Only one y value. Okay, if I look at D, and I plug in a 1 cubed as well, that's going to be 1 times 1 times 1, which is going to give us 1. Now in this case, it might have been more beneficial to maybe pick a negative. We can also try a -1, and we would get different solutions. So you can go through it, just make sure you use parentheses, and don't assume just because you see a power that it's always going to come out positive. Okay, so for this one, we should have also selected D. Okay, moving on to number 3, it says how many y values are there for each x value in the given function? So how many outputs are for every x value? So if you remember when we learned this in class, this is this thing called the vertical line test. So if I look right here at -2 and I check it, there's one value here. If I look right here at 0, there's one value here at -4. If I look right here and now were to go any vertical lines through the whole thing, I would see that it hits that line only one time, which tells me that there is only one y value for each x value in this graph. Again, that's our vertical line test. Okay, number 4, I'm going to kind of go back and forth because it's a little hard to see, but we need to reference number 3, but it says which statements about all of these functions in item 3 are true. Select all that apply. So some input values are negative. So if I remember, input is our x's. So if I go down here, do I have any x values that are negative where my graph is? And I look, yes, absolutely I do. So I'm going to bubble in A for that one. Then I'm going to go to B. Some output values are negative. That's what means by y. Are there any y values that are negative? Well, if you look, our line is like as if it was underwater. It is all of our values are actually negative. So it does say some, which is not the best wording, but we know for sure that at least some of them are negative. Eventually it would go up to the top if we were to continue that line. C, some input values are integers. If we remember, integers are kind of like whole numbers or things that we've talked about. And so if I look, are some of my input values integers? Do I have integers? Absolutely. We check some of them with our vertical line test. So I'm going to go ahead and I'm going to bubble in C. Then I go to D. Some output values are integers. Some of my y's. Are some of my y's that come out, are they integers? Well, yeah, as we saw right here, let's use a different color. When we had our 0 value for our input, a -4 is what came out. And so we have some integers as well. And so for this case, we are also going to select D. So for number 4, all 4 of them are actually correct. Going to number 5, which ordered pair is the solution of the equation? Now you could go through and you could graph it, you could find it. Might be a little bit hard to find this though on your graph. So we're going to go through and we're going to plug in our x and our y values. So we're going to add another sticky note. And we are going to see which one works. So let me erase some of these guys so we got some space. So I'm going to start with A and I'm going to say -8, 8 is my first coordinate. So remember, first value is my x, second value is my y. And I'm going to write my equation, y equals -5/4 x minus 2. And I'm going to substitute x and y for those numbers I have up above. So for my y, I'm going to plug in an 8. That's positive. I'm going to have -5/4, and then I'm going to plug in a -8. And then I'm going to go through and I'm going to do the algebra. So I'll do -8/1. Some of you might see that you can simplify the 4 and the 8, but just in case, we'll go through and we'll do it. So I'm going to have 8 equals a negative times a negative gives me a positive. And then I'm going to have 5 times 8 is going to give me 40. And then I have 4 times 1 on the bottom, which is going to give me 4. And this is a nice one because I have 40 divided by 4, which is just going to give me 10. Oop. So I'm going to have 10 minus 2. And 10 minus 2, so I'll bring it up here. I have 8 equals 10 minus 2. 10 minus 2 is 8, and so we see that this one works. Okay, so A, in this case, our first one works. If we were to plug in B and we were to switch the negatives, the negative to the y value, this one wouldn't work. Okay, if you want to try another value just to practice to see if it doesn't work, you could try C as well, and then D also does not work. All right, moving on to number 6. This one, we have to determine what our y value is. So they give us a line, or equation of a line, and they tell us what the x coordinate is, but we have to figure out what the missing y coordinate is. So just like what we did in number 5, we know that -1/4 is already 1. We just need to plug it in and figure out our y. So we're going to do 3y plus 4x equals 5. And Lincoln's here to help. So substituting in for our x, we're going to put -1/4, which is nice because we have a 4. So we're going to say 3y plus 4 times -1/4 equals 5. So if I go through and I do this algebra, let's get a lighter color. Okay, this is like going to be a 4/1. And if you notice the reciprocals, one's just the opposite. So I'm actually going to add a sticky note so we can see a little bit better. We're going to say 3y plus 4/1 times -1/4 equals 5. And I'm going to have 3y equals -4/4, excuse me, not equals, plus. Equals 5, so I have 3y minus 1 equals 5. I solve for y, I add 1 on both sides, 3y equals 6, divide by 3, and y equals 2. So we end up with our value being 2 for our y. So we plug it in here, we end up with 2. Okay, moving on to number 7. A line that passes through the points -6, -3, and 6, -3. So right away we should notice that these y values are going to be the same. So you can use a piece of graph paper, plot these points, and you'll see. So if I were to put a piece of graph paper just to show you guys, let me get one with a little bit more lines. Okay, or even if you use the graph below, it doesn't have quite all the numbers. But if we go through and we draw our y-axis, that was a pretty awful line. draw our x-axis, and we're going to plot at negative 1, 2, 3, 4, 5, 6, negative 1, 2, 3, and then we're going to go positive 6, 1, 2, 3, 4, 5, and we'll say 6, and then we'll go down 1, 2, negative 3, and we see, hopefully you remember, oh, Lincoln's helping me, that we have what type of line? It starts with an H and ends with horizontal. We have a horizontal line. And the way we can tell that even if we didn't have a graph is because our y's are both negative 3. So technically what we're looking for in any of our multiple choices is we see if there are any y values that are negative 3. So if I look at A, we say, nope, it doesn't have any. If I look at B, it doesn't have any. If I look at C, yep, 0, negative 3. So if I were to even to plot this point, 0, negative 3, we would see that it is on that line. So we end up with C for this option because our y value is negative 3. Alright, and then moving on to the last question. This is just saying graph the linear function, so hopefully we know this from last semester. This is y equals mx plus b, but it's good remembering. So our m and our b, we're going to write down what they are. So our m value is going to be 2, but remember we write it as a fraction. Anytime it's a whole number, you put it over 1. So 2 positive means we're going to go up 2, and 1 positive means we're going to go right 1. Our value of b is going to be 3. So b is where we start at, where we begin. So we're going to start at b on the y-axis, and we're going to go up 2, right 1. Now we run out of space, so remember, this is the same. Let's use the equal sign so we don't get confused with all the arrows. This is the same as negative 2 over negative 1, because a negative over a negative makes a positive. Which means I can also go down 2 and left 1. Down 2, left 1, down 2, left 1, until it's covered my whole graph. And there you have questions 1 through 8 for Ready Assessment number 3.